Have you ever looked up at the night sky? Have you seen the countless stars scattered across the darkness? Perhaps you felt a sense of wonder, a feeling of how small we are in such a vast universe. This feeling connects us to every human who has ever lived. For thousands of years we have gazed at the cosmos and asked a simple yet profound question. Are we alone? This question is not just a scientific curiosity. It is a deep part of what it means to be human. It drives our stories, our art, and our greatest adventures into the unknown. This fundamental question has echoed through the halls of history. It has been whispered by poets and shouted by philosophers. It has been pondered by ancient storytellers around a fire. It has been calculated by scientists in modern observatories. The universe is unimaginably large. Our sun is just one star among billions in our Milky Way galaxy, and our galaxy is just one of billions of galaxies that we can observe. The numbers are so huge they are difficult to comprehend. In this immense cosmic ocean, it seems almost arrogant to assume that our small blue planet is the only place where life has taken hold. The laws of physics and chemistry are the same everywhere. The building blocks of life, like carbon and water, are abundant throughout the cosmos. For most of human history, our ideas about life beyond Earth were based on imagination. Ancient cultures filled the heavens with gods, spirits, and mythical creatures. The planets and stars were not seen as physical worlds, but as divine beings or celestial signs. The moon might be a goddess, and Mars a god of war. The great shift began with the invention of the telescope. Suddenly, the heavens were brought closer. Astronomers like Galileo Galilei turned their new instruments to the sky. They saw that the moon was not a perfect, smooth sphere, but a world with mountains and valleys. They discovered that Jupiter had its own moons, a miniature solar system orbiting another planet. The planets were transformed from points of light into worlds in their own right. This sparked a revolution in thinking. If other planets are worlds like ours, could they also be home to life? The 19th century brought more powerful telescopes and a growing desire to find concrete evidence of life beyond Earth. Mars, our mysterious red neighbor, became the primary focus of this intense curiosity. In 1877, the Italian astronomer Giovanni Schiaparelli observed a network of faint straight lines on the Martian surface. This idea was championed most famously by the American astronomer Percival Lowell. He spent years meticulously mapping hundreds of these lines, elaborating on the theory that they were a massive irrigation system built by a dying Martian civilization. In the middle of the 20th century, something changed. Our own technology had advanced to a remarkable point. We had built radio transmitters powerful enough to send signals into space. We had also built radio telescopes, sensitive enough to receive faint whispers from the cosmos. For the first time in history, we had the tools to turn our ancient question into a real scientific experiment. The scientific foundation for SETI was laid out in a landmark paper in 1959. Two physicists, Philip Morrison and Giuseppe Cocconi, published an article in the journal Nature. The first person to turn the theory of SETI into practice was a young American astronomer named Frank Drake. In the spring of 1960, at the National Radio Astronomy Observatory in Green Bank, West Virginia, he launched a modest but historic experiment. He named it Project Ozma, after the princess from the fantasy land of Oz, a distant, hard-to-reach place populated by strange and wonderful beings. For several months, Drake and his team carefully scanned the frequencies around the so-called magic hydrogen line. They used a single-channel receiver, slowly tuning it across the dial, listening for anything that sounded artificial. In the long and patient history of SETI, there is one event that stands out above all others. On the night of August 15, 1977, a radio telescope in Ohio was listening to the sky. Suddenly, it picked up a signal. It was not the usual random static of the cosmos. This was something different. It was a powerful narrow-band signal, exactly the kind of transmission that SETI researchers had been hoping to find for years. The signal lasted for a full 72 seconds, the maximum time the Big Ear telescope could observe any single point in the sky as the Earth rotated. Then, it was gone. So what exactly is alien technology? When scientists search for it, what do they hope to find? In simple terms, they are looking for evidence of intelligence. They are looking for something that nature could not create on its own. This could be anything from a deliberate signal sent across space to a physical object built by an alien civilization. The key is to find an artifact or a phenomenon that is clearly artificial. It must be something that breaks the known rules of natural cosmic processes. The most famous type of search is the hunt for alien signals. This is the main focus of projects like SETI, the search for extraterrestrial intelligence. The idea is that an advanced civilization might use radio waves to communicate, just like we do. Scientists use massive radio telescopes to scan the sky, listening for a signal that stands out from the natural cosmic noise. They are looking for a narrow, powerful signal that has a clear, repeating pattern. We are also looking for extremely brief, powerful flashes of laser light. These laser pulses would be very efficient, and for a fleeting moment, they could outshine the star they are coming from. An advanced civilization might leave behind other clues. Imagine a civilization far more advanced than us. They might be able to harness the energy of their entire star. A physicist named Freeman Dyson proposed that such a civilization could build a massive structure around their star to capture all its power. Back in 2015, astronomers using NASA's Kepler Space Telescope were studying a star about 1,500 light-years away. The star was dimming in a way that no one had ever seen before. The dips in light were not small and periodic, but massive, deep, and completely irregular. Such a structure would block the star's light, but it would radiate enormous amounts of infrared heat. We could potentially detect this heat signature with our infrared telescopes. The primary tool in our search for alien technology has long been the radio telescope. These enormous dishes, some as wide as a football field, can detect incredibly faint signals that have traveled across light years of empty space. Today, modern SETI projects use receivers that can listen to billions of channels simultaneously. This incredible leap in capability means we can survey the sky far more quickly and thoroughly than ever before. Projects like the Breakthrough Listen initiative are using the world's most powerful telescopes to conduct the most comprehensive SETI survey in history. While our ears are tuned to the radio spectrum, our eyes are also searching for signs of alien technology. To find these fleeting flashes, astronomers use special telescopes equipped with detectors that can record incredibly fast changes in light. These searches scan star after star, looking for a sudden spike in brightness that lasts for only a billionth of a second. Such a signal would be very difficult to explain as a natural event. This method uses space telescopes like Kepler and the Transiting Exoplanet Survey Satellite, or TESS, looking for irregular, deep, or non-periodic dips in starlight. In 2017, our solar system received its first confirmed visitor from another star. An object, later named Oumuamua, was detected streaking through our planetary neighborhood. What they found was deeply strange. Oumuamua was unlike any comet or asteroid ever seen before. Most remarkably, its shape was thought to be extremely elongated, perhaps 10 times longer than it was wide, like a cosmic cigar or a flat pancake. As Oumuamua moved away from the sun, it did something unexpected. It accelerated slightly. It was moving faster than gravity alone could explain. The search for alien technology is one of the grandest scientific quests in human history. But you might be surprised to learn that you do not need a PhD in astrophysics to be a part of it. One of the most famous and successful citizen science projects in this field is SETI at home. This brilliant project, launched in 1999, used the combined processing power of millions of personal computers around the world. Millions of people participated, creating a global supercomputer dedicated to the search and proving that public enthusiasm for this question is immense. Perhaps you do not have the time to actively participate in a citizen science project. That does not mean you have to be left out of the adventure. Following the search for alien technology has never been easier or, honestly, more exciting. The scientists and organizations leading this work are passionate about sharing their journey with the public. They understand that this question belongs to all of us. Major research initiatives have dedicated websites and social media channels where they post regular updates on their observations, explain their methods, and announce any interesting signals or findings. Underpinning all of these search methods is one of the most powerful tools of all: artificial intelligence. The amount of data being collected by modern telescopes is staggering. We can train sophisticated algorithms to sift through these mountains of data, looking for the needle in the cosmic haystack. These AI brains can be taught what a promising signal looks like and can spot subtle patterns or anomalies that a human observer might miss. New and more powerful telescopes are being built, both on the ground and in space. Technology is advancing so rapidly that the searches of tomorrow will make today's efforts look primitive. The search for alien technology is more than just a hunt for distant signals or strange objects in the sky. It is also a profound journey of self-discovery. When we gaze out into the cosmos and wonder about other forms of intelligence, we are inevitably forced to look back at ourselves. What does it mean to be an intelligent technological species? What is our place in the grand cosmic scheme of things? The very act of searching for others holds up a mirror to humanity. Thinking about how to find another civilization makes us think about our own footprint. We look for their waste heat, their atmospheric pollutants, and their leaked communications. Furthermore, this great endeavor has the power to unite us. In a world often divided by borders, cultures, and beliefs, the search for extraterrestrial intelligence is a fundamentally human project. It is a question that transcends all our terrestrial differences. The night sky is the same for everyone on Earth. The possibility that we might one day make contact with another intelligence is a concept that can inspire all of humanity together. The search reminds us that we are all crew members on the same small spaceship Earth, traveling through the vastness of space. Our search for alien technology has only just begun. For all our efforts, we have explored only a tiny fraction of the cosmic ocean. The fact that we have not found anything yet is not surprising. Imagine for a moment that the search succeeds. Imagine that tomorrow an announcement is made. A team of scientists, after years of patient listening, has detected a signal. It is unambiguous, it is complex, it is intelligent, it is not from Earth. The confirmation that we are not alone in the universe would be, without any doubt, the single most profound discovery in all of human history. The future of the search is bright and filled with promise. The Vera C. Rubin Observatory will scan the sky with unprecedented speed and depth. The James Webb Space Telescope and its successors will be able to sniff the atmospheres of Earth-like planets. The journey forward is one of constant learning, adapting our methods and expanding our minds to new possibilities. The quest requires patience, persistence, and an unwavering sense of optimistic curiosity. And so we continue to look up. We continue to listen to the whispers of the cosmos. We carry forward the same question that our ancestors asked as they gazed at the stars from the plains of Africa or the valleys of ancient Greece. Are we alone? The answer, whatever it may be, awaits us out there in the vast and silent darkness. The search is a testament to the best parts of our human nature. Our relentless curiosity, our boundless imagination, and our deep desire to understand our place in the universe. It is one of our greatest adventures, and the story is far from over. The hunt goes on.